See, last class we discussed solve by matrix method. Now, today we will take solution of system of equations. Solution of system of equation. For that, just I will consider the example. See, x plus y plus z is 9. And another one is 2x minus y plus z is 5. 4x plus y minus z is equal to 7. These are the three equations. Okay, these are the three equations. If we substitute any values of x, y, z, so that you can get 9, 5, 7. If we substitute any values of x, y, z, so that they can get the value 9, 5, 7. Then that values of x, y, z we call it as solution of system of equations. That is, for example, if I take x is 2, y is 3, z is 4. Substitute here. 2 plus 3 plus 4, 9. Next, 2 into 2, 4. Minus 3 plus 4, 5. Next, 4 into 2, 8. 3 minus 4. What do you get? It is 7. Okay. See, x is 2, y is 3, z is 4. These three values x, y, z will satisfy all the three equations. And that one we call it as solution system of equations. Okay. See, a definition is a set of values of x, y and z. What is the definition? A set of values of x, y and z which are simultaneously satisfy all the equations. Simultaneously satisfy all the equations called solution of the system of equations. Called solution of the system of equations. I think now you are understood. I hope. And based on that, we have done already solve by matrix method. The same what we have done in solve by matrix method. The same one. Okay. Next, I will take one example. See an example. X plus 3y is 5. X minus y is 1. Okay. X plus 3y is 5, x minus y is equal to 1. These two are the equations and we have to substitute the value of x and y simultaneously so that it satisfies 5 as well as 1. Tell me that values, and that one we have to calculate by using which method? Solve by matrix method, because as already we have studied, or in generally if I substitute, see x is 2, if I substitute x is 2, y is 1. See, 2 plus 3 into 1. What will you get? It is 5. Next, 2 minus 1. What will you get? It is 1. Means we say that x is 2, y is 1. X is 2, y is 1. His solution of the system of equations. You understood? Okay. Next, come across consistent equations. Next step is consistent equation. If the system of equations, see, if the system of equations has one or more solutions, you understood? If the system of equations has one or more solutions, then it is said to be consistent of equations. Otherwise, it is an inconsistent system of equation. Okay. See, we consider this example. See here, how many number of solutions are exist? 2 solutions. See, x is 2, y is 1. And when we say that a consistent, if the system of equation has one or more solutions. Of course, here how many number of solutions? 2 solutions. We say that this one is a which type of equation? Consistent equations. Okay. Next, I will give the conditions for the consistency equations. Conditions for consistency of a system of linear equations. Okay. First condition, determinant A not equal to 0, then the system is consistent. Then the system is consistent and it has unique solutions. Second, if determinant A equal to 0, then adjoint A into D not equal to 0. Adjoint A into D not equal to 0. Then the system is inconsistent. Okay. Next, third condition we have to remember. If determinant A equal to 0 and adjoint A into D equal to 0, then the system is consistent and it has infinitely many solutions. This is the condition for the consistency of a system of linear equations. Okay. Very first step is what? Determinant A not equal to 0. We know that if determinant A not equal to 0, A inverse exists. A inverse exists means naturally the value of x, y, z are exist. Therefore, the system is what? Consistent. Because we know that if system has one or more values, such type of equations we call it as consistent. Therefore, of course, here the given system of equation is consistent. Next, if determinant A equal to 0, we say that in general if determinant A equal to 0 singular matrix, then there is no solution. But there is a condition here. If determinant A equal to 0 and adjoint A into D not equal to 0, there is a condition, adjoint A into D not equal to 0, then the system is inconsistent. We will verify by taking the example, don't worry. Next, if determinant A equal to 0 and adjoint A into D equal to 0, then we say that system is consistent, but it has how many number of solutions? Infinitely many solutions. Okay, please remember these three conditions for consistency. Usually ask in the exam such type of examples for 2 marks, and it is enough to prove that what if it is of order 2 cross 2, the condition we are applying. If order 3 cross 3, usually verify determinant A not equal to 0 or equal to 0. That is enough. Okay. Next, examine the consistency. Examine the consistency of the following system of equations. Okay. Example, x plus 2y equal to 2. 2x plus 3y equal to. This is the example. Okay, solution. Take let matrix A, coefficients of x 1, y 2, 3. You know that already how to calculate this one because so many examples we solved in matrix. Now we are applying determinant A. Determinant A, rule of cross multiplication. 1, 2, 2, 3. 3 minus 4 minus 1, which one? Not equal to 0. See, determinant A not equal to 0, it is easy to verify. It is easy to say that it has which type of equation? Consistent. It is an equation. Remember that. Okay. Next step. Next example. X plus 3y. X plus 3y is 5. 2x plus 6y. 2x plus 6y equal to 8. 2x plus 6y equal to 8. For that I will consider matrix A. Matrix A, coefficient of x1, y3, x2, y6. Okay. That is the determinant A. 1, 3, 2, 6. Means we get 6 minus 6, 0. If determinant A equal to 0, there are two types of condition. That is, we have to verify adjoint A into D not equal to 0 or equal to 0. If it is equal to 0, infinitely many solution. Not equal to 0 means it is not consistent. Okay. Next, calculate cofactors of A. Cofactors of A. And we know that how to calculate cofactors of A. Correct. That is C. Cofactor of 1. Leave the row, leave the column, we get 6. And for 3, leave the row, leave the column 2. For 2, leave the row, leave the column 3. For 6, leave the row, leave the column 1. And we know the proper sign is plus, minus, minus, plus. Okay. And next, adjoint A. Adjoint A is transpose of this matrix 6 minus 2 minus 3. Next, calculate adjoint A into D. That is 6 minus 3 minus 2, 1 into D, 5, H. Okay. Multiply. Next. Multiply. First row 1, first column. 6 5s are 30 minus 3 8s are 24. Next, minus 2 5s are 10. 1 8s are okay. 30 minus 6, 30 minus 24, 6 minus 10 plus 8 minus 2. Which one? Not equal to 0. Means adjoint A into D not equal to 0. Means this is which type of equation? See, we have the condition if determinant A equal to 0 and adjoint AD not equal to 0, such we say that it is an inconsistent or not consistent. Correct? We say that it is not a consistent equation. If you want, you can verify any number of x and y will not get at a time both 5 and h. Okay. Next example. I will take next example. X plus 3y. Next example is x plus 3y is 5. 2x plus 6y. 2x plus 6y is 10. Okay. See, solution. Let matrix A, coefficient of x1, y3, x2, y6. Okay. we know that x bar, and D we know that pi 10, as you know in matrix method how to calculate. Next, calculate determinant A, that is 1 3 2 6, cross multiply. 6 minus 6 equal to 0. Determinant A equal to, means again we have to verify the condition, that is cofactors of A. Correct? Cofactors of A. Calculate. 1 cofactor, leave the row, leave the column. 6. For 3, leave the row, leave the column. 2. For 2, leave the row, leave the column. 3. For 6, leave the row, leave the column. 1. Apply. Plus, minus, minus. Next, adjoint A. Adjoint A is transpose of this matrix. 6 minus 2 minus 3, 1. Next, adjoint A into D. That is 6 minus 3 minus 2, 1 into D. It is our D, 5. Okay, multiply first row by first row. 6 5s are 30. 10 3s are 30. Minus 2 5s are 10. 10. What you get is 0 0. Means adjoint A into D is 0. Adjoint A into D is 0. Means we say that it is a consistent. Correct? It is a consistent. But how many number of solutions here? Infinitely many solutions. Infinitely many solutions. If you want, you can verify. See, if I take x is 2, y is 1. If I apply, see, 2 plus 3, we get 5. Next, 2 into 2, 4 plus 6, we get 10. This is one solution. X is 2, y is 1. Next one, another one I will take solution. That is x is minus 1, y is 2. If I take, apply, minus 1 plus 3 into 2, we get 5. Next, 2 into minus 1 plus 6 into 2, we get minus 2 plus 12, we get 10. Means see here, this is also a solution of this equation. This is also solution of this equation. You can take another one is also solution of this equation. Means if remember that if determinant A equal to 0, then adjoint A into D equal to 0, then we say that system of equation is consistent, but it is how many number of solutions? Infinitely many solutions. These are the 3 examples what I solved based on the 3 conditions. Remember that if determinant A not equal to 0, if determinant A not equal to 0 means, remember that always it is consistent and it has unique solution. If determinant A equal to 0, adjoint A into D not equal to 0, then it is not a consistent. If determinant A equal to 0 and adjoint A into D equal to 0, means it is consistent, but it has how many number of solutions? Infinitely many solutions. Now I will give one example for homework. That is x plus y plus z is 1, 2x plus 3y plus 2z is 2, x plus x plus 2y plus 2z is verify is this equation consistent or not consistent. I hope understood. And usually such type of examples are asked in the exam for maximum 2 marks question. Maximum 2 marks question. Okay, thank you.